So that's also a common misunderstanding. People think it's only for big data. That's what it was built for over 10 years ago at LinkedIn. But today, over 50% of use cases I see are about transactional workloads. So this is also another myth where people say, I should always use JMS for transactional workloads. So that's not true. You can use it and there's some pros and cons, right? But you need to understand that you can also use Kafka for transactional workloads.
From Toro Cloud, this is the Coding Over Cocktails podcast, a free pool of thoughts and ideas from IT experts, thought leaders, and authors, sharing their insights and advice for individuals architecting solutions for the ever-changing landscape of enterprise tech, digital transformation, and more. Welcome to episode 66 of the Coding Over Cocktails podcast. My name is Kevin Montalvo, and joining us from Sydney, Australia is Toro Cloud CEO and founder, David Brown. Good day, David.
Hi there, Kevin.
All right. On this edition of the Coding Over Cocktails podcast, we're going to have a tech smackdown, putting forth two technologies or architectural styles in a friendly sparring match. Today, we're debating between two messaging services, JMS versus Kafka. Which message broker should you choose? On the JMS corner is a Java champion, senior principal software engineer, and reactive architect at Red Hat. He has contributed to several projects and products touching many domains and technologies such as OSGI, mobile, continuous delivery, and DevOps. More recently, he focused on reactive systems, cloud-native applications, and Kubernetes. He is an active contributor to many open-source projects such as Apache Felix, Eclipse VertX, Small Rye, Mutiny, and Quarkus, and he recently authored the Reactive Systems with Java book. Joining us today to represent the JMS side is Clement Escoffier. Hi, Clement. Welcome to the show.
Hello. Thank you for having me.
On the Kafka corner, we have the field CTO and global technology advisor at Confluent. He works with customers across the globe and with internal teams such as engineering and marketing teams within organizations. His main area of expertise lies within the fields of data streaming, analytics, hybrid cloud architectures, Internet of Things, and blockchain. He's also a regular speaker at international conferences such as DevOps, ApacheCon, and Kafka Summit, and writes articles for professional journals, sharing his experiences with new technologies on his blog. Representing the Kafka side is Kai Waehner. Hi, Kai. Welcome to the show.
Hey, everyone. Thanks for being here. Great topic to discuss today.
Oh, thank you. Thanks. It's a pleasure to have you both on the program. We actually came up with this topic because it's one of the more popular blogs on our website. There's still obviously a lot of interest from our readers on this topic of JMS versus Kafka. It has a lot of search volume as well. So it's still obviously pretty relevant today. So before we jump into the relative advantages and disadvantages, maybe we can just give a brief outline. I'll get each of you to give a brief outline of the problems that each platform is trying to solve. So maybe, Clement, you can start us off by describing, JMS has been around for a while. What is the solution that and what problems does it try to solve?
So JMS is around for a long time, probably 20 years or something like this. It's actually aged relatively well if we look at other technologies that come from more than 20 years ago. So the problem they tried to address was really to have a way to implement asynchronous communication between different applications or different parts of one system. Very quickly it became popular for this integration pattern and EAP, so enterprise integration patterns, because, well, it was the beginning of the rise of what we called ESB and things like that. So we needed a bus to exchange those messages between various applications or part of your systems. So JMS is Java-centric, and the J is for Java. However, implementations generally rely on different protocol. If we take Artemis or ActiveMQ, they have their own core protocol implementing JMS on top of that. And generally, when you use a JMS broker, you actually have a set of protocols that are offered. It's not necessarily one, a specific one. Typically, I'm mostly recommending using IMQP 1.0 because it's The A of AMQP means advanced, and believe me, they don't lie about the advanced part. It's a complicated protocol, but it's very, very well done for cloud and things like that. So the one of the advantage of GMS is that it's really Java centric. So, okay, you have to use Java, but you have these other protocols that you can use. But it's a clear semantic when you are in Java. You know exactly how it's going to work. You have two types of delivery, queues and topics. And be careful because the topics of GMS is different from the topics from Kafka. So we will always have to mention what kind of topics we are referring to. So a GMS queue, it's a queue of message. You have messages inside your queue. You have a set of consumers and they share the load. It's unbounded, so you can have as many consumers as you want. So it's a big advantage on the cloud because you can scale up and scale down according to the depth of the queue. It has delivery guarantees and things like that, so it has persistent durability and so on. Topics is a pub sub implementation in the sense that all the messages will be broadcasted to all the consumers. So I won't go into the detail of how it's implemented, but basically it means having a queue per consumer. So it's just a copy of the messages. So based on this two relatively simple, well understood delivery mechanism, GMS has successfully handled a lot of problems for the last 20 years. And we find it in banking systems, in smaller applications where asynchronous is important, like ordering system or logistics or even IoTs these days. It works relatively well on the cloud on things like Kubernetes or in containers because it doesn't have any consumer limits when you have queues. However, it has a few downside. Typically ordering. Well, you can't. You don't know what the order. It can be quite different, which is one of the things where Kafka is very good.
Right. You're not arguing for Kafka here.
Yeah, it is.
But we'll let Kai raise those disadvantages.
I generally speak about both, so that's why.
You're being too honest there. You got to.
Okay, so no, don't do. So, but it has. If you're looking for hybrid cloud. Kind of thing. So hybrid cloud is a system where you have multiple data centers, multiple cloud providers. So your application is either replicated or collaborate across clouds. In that case, the filtering and transferring capabilities between one data center to another one of GMS and of the underlying protocols are very, very advanced with fine-grained tuning and things like that. So you can only copy the messages which will be actually consume on the other side and things like that. So you have lots of flexibility. That's more or less it. It's been popular for almost 20 years. It's still heavily used. We have lots of demands around GMS. As a member of the Quarkus team, it's quite popular. We have a connector for GMS, a connector for Kafka. Of course, these days we have more demand around Kafka because, it's hype and people want to use it. It's very cool technologies. But when people do migration, when people have more legacy kind of systems, GMS is still whereas things are happening.
You did mention a couple of the legacy applications that like ESB type architecture from the legacy applications, but as you said, they're still relevant today for pub sub type architectures and queue type applications as well. So Kai, maybe you can start on what if JMS was doing all this so well, has been around for 20 years. What brought about the need for Kafka?
That's a great point. And so first of all, I really want to make clear that in the end, we are comparing apples and oranges here, right? And even more crazy than that, I would even say that not both are fruits. Because on the one side, if you talk about JMS, and that's why I really want to emphasize this, This is a standard protocol, right? So this is a standard, a specification, and you need to implement it. And then Red Hat has Artemis, and then IBM has IBM MQ, and everyone has a different implementation. So this is the first big difference. And therefore, a move about just using one broker and then migrating to another vendor, that's not true. And we can discuss this later today. So that's the one point. So we're not really comparing apples to oranges because Kafka is a protocol implementation. If you use Kafka, it doesn't matter if you use Confluent Kafka or if you use IBM's Kafka or Red Hat's Kafka. If it's Kafka, and it works, right? You can just use it. So that's the first big difference. And the second big difference, and this is also now where we see that both are relevant today, because as we now just heard, the JMS broker, whichever you use, is a messaging broker. You use it for sending data from A to B, and it's very simple and understood and works well for that. On the other side, Kafka is a very different technology. It's what we call an event streaming or data streaming platform. And with that, on a high level, I always explain it as 4 things. And therefore, in the intro, it's really funny because we heard that we are comparing to messaging brokers, but that's not true, because Kafka is 4 things in the end. It's a messaging broker. So that's the part you can compare to the JMS broker. And in combination with that, it's a storage system. That's where the JMS broker is partly like that, but much less, so a little bit. And in addition to that, with Kafka, and I'm really just talking about open source Kafka, right? Not about any vendor like Confluent or anything else. It's also a data integration platform with Kafka Connect. And it's also a stream processing platform with Kafka Streams. That's all part of the single Apache Kafka download you have. And with that, you see that with Kafka, you can do many things. And it's much more than just a messaging broker. If you want to do data integration, at Red Hat, for example, use Apache Camel, which is a fantastic framework. So I worked for Talent 10 years ago, and I loved that framework. But you need more components for that. And I also worked for TIBCO before, so I know the messaging part well and the stream processing part. And this is really on a high level, the 2 points for Kafka. It's implementation. It's not a standard where you have different vendors. It's an implementation. And on top of that, it's much more than messaging. And this is the difference. And why now in the future, we will still see both, because it's very different use cases. For pub/sub messaging from A to B, at least if scale is not extreme, then JMS and brokers are great for that. For anything else, people use Kafka more and more. And the key point here is you can use it for transactional workloads and analytics workloads. So that's also a common misunderstanding. People think it's only for big data. That's what it was built for over 10 years ago at LinkedIn. But today, over 50% of use cases I see are about transactional workloads. So this is also another myth where people say, I should always use JMS for transactional workloads. So that's not true. You can use it, and there's some pros and cons, right? But you need to understand that you can also use Kafka for transactional workloads.
So there is a bit of crossover in that regard. Like you said, there's a bunch of stuff that Kafka does where it's not really comparable to JMS, but there is some crossover in terms of the message broker. And as you said, it's now handling transactional workflows, which has been the traditional domain of JMS. So how would, if we were to focus in and zoom in on those areas where there is crossover, forgetting about the vendor aspect of the different vendors of JMS brokers, and just talking about the protocol versus Kafka, what are the relative advantages and disadvantages? When should you choose one or the other as a message broker? Clement, what would you say to that?
It's an interesting question because, well, when you need pure asynchronous communication from A to B, typically, GMS tends to be simpler, better understood. Not going too deep, but Kafka looks simpler. And you can do an hello world in Kafka faster than an hello world in GMS. Definitely. Just starting the JMS broker will take more time than doing the whole thing. However, there is plenty of things you need to understand to use and operate Kafka very well, while GMS has learned over these 20 years to try to improve that, to make sure that, you don't shoot yourself. So, for example, when you write, yes, you get acknowledgement based and things like that. It's pretty simple. You know when it's written and when you consume. When you are done, you acknowledge, period. That's it, done. well, if you want to do this on the Kafka side, it's a little bit more tricky because you need to commit offset, not every time, because that's a very bad things to do. And Kai may explain why. So you need to have offset management and check. And when you commit an offset, that means that every record before that has been processed successfully. So as soon as you do asynchronous things in the middle, it can be tricky. So yeah, this simplicity as simple doesn't mean bad. Simple means that it's easy to use for most developers that don't necessarily want to have a degree in messaging or streaming technologies. They can go there. They know, okay, simple. I do a producer. I get my acknowledgement when it's returned. I even have a blocking API where I know that it's going to block until it's written. You have timeouts and things like that. On the other side, yeah, same thing. Once I get a message, you get message one by one, not by batch, as Kafka is recommending. So you get the message one by one, you process it, acknowledge, period. You can easily filter. So, oh yeah, I want only the messages with that header or with that content type or coming from that destination and things like that. So the filtering capabilities are very interesting too. And again, it has really been designed to be relatively easy to understand. Again, well, we need to remember that most developers don't necessarily want to spend their nights and weekend trying to understand all the nasty details about what a synchronous flush on the file system is and things like that. So I want to get the job done. So,
Kai, what would you say to that JMS is a simple and mature framework? What would be your response to that?
No, I fully agree to that, right? So that's totally true. In the end, it's very simple because, again, the main idea is to send data from A to B. And if that's your main goal and the only thing you need to do, then a JMS broker is the right choice, very likely, right? Because with Kafka, you do much more. For most use cases we see, it's not enough to just send data from A to B because you also want to use it and correlate it in real time and integrate with systems. Some are real time, some are not a real time, like a data lake. And so use it for a much bigger space. And that's why it's, again, this apple to orange comparison. And I always recommend, think about the whole use case, not just this broker part. That's my first thing, right? But nevertheless, now we should still talk about this comparison only of the broker. Even there, it's important to understand the differences. And there are differences which have pros and cons, like were already mentioned. And in the end, it's totally true that JMS has this simple API you just send and consume. On the other side, with Kafka, then you can do much more with that. And you have things out of the box like guaranteed ordering. And that's things for critical business applications you get out of the box, so you don't have to worry about that. And therefore, it has always pros and cons. The one thing what I would say about JMS API is really better if you need some communication paradigms like request reply, right? You can do that easily with Kafka, but it's a pattern around it. You implement it differently. With JMS, you have it out of the API. So that's the thing where it's just messaging, right? But then for the filtering part, so a Kafka broker is dumb. You don't do filtering on the Kafka broker. That's very different from a JMS broker where you do things like filtering. In Kafka, this was implemented like this intentionally because it's not good for a scale. So in Kafka, and that's why we also take a look at the whole ecosystem. You do the filtering and processing in its own application, which can be, for example, a Kafka Streams application or a KSQL application. So it's a different kind of architecture and depends on the use case. Once again, if you just want to send the data from A to B and maybe filter it and do that at a relative small scale, then the JMS broker is the right choice. In other cases, it's typically more like Kafka is the better fit. And the last part, and this is also a very critical one, which people often don't understand well, is that the kind of how you consume data is very different in Kafka and in a JMS broker. In a JMS broker, it's push-based, which means the broker pushes the data to the consumer, right? Which sounds more obvious because people say, yes, I want to get data in real time, event by event. Well, reality is that this also creates pressure on the consumer. And especially in a world where you have different consumers in a microservices world, you need things like back pressure handling. And that's built into the Kafka protocol because it's pull-based. So each consumer decides by themselves when and how often to consume data. The drawback of this is, and that's what was already explained by Clement, is that you need to understand how it works. It's not just like the JMS API, you get it. But therefore, you have all this power to get it right for your application, because your data warehouse is not built for real-time ingestion. It's built for taking snapshots of data, like the last 100 messages, and ingest it at once, because the indexing layer of the data warehouse doesn't work better. It's not the problem of the messaging layer. And so with that, you have the built-in back pressure handling so that each consumer can consume it like they need. And still, the argument about that getting messaged one by one, well, in the end, the consumer wants to get data in guaranteed ordering. And reality is that the latency is so low with Kafka, it doesn't matter if you consume 10 or 100 messages at once, right? You can do one by one, but it's not recommended because the performance is worse then, obviously. But we are here talking about a few milliseconds. And this is another point maybe where I would say that both JMS brokers and Kafka are not the right choice. If you need low latency things like real trading in microseconds, that's not either of that. That's completely different application. And as soon as we talk about real time, for 99.9%, it doesn't matter if you get the data in 10 milliseconds or in 20 milliseconds at any scale. And so this push versus pull based is super important to understand. And the pull based is not as worse as some people think, because again, you have the back pressure handling built in there. And the big other difference between how JMS brokers typically work and how Kafka works. And I say typically because, again, JMS is a standard, so you can implement it like you want. And if you use different brokers, they work differently for things like security, for things like network transfer, for things like disk persistence. So you don't have the same SLAs and guarantees. So you need to check with the vendor behind that and the support. With Kafka, you have the storage system behind it. It's implemented into the protocol. And with that, the benefit of it is you store the data in Kafka as long as you want. And you can decide that per Kafka topic. And in addition to the back pressure handling with that, so sometimes you have not just batch consumers, but also consumers that consume the data really late, like a week later, or maybe a request response from a web app about a data that came in a year ago. So you can easily replay data that is old, completely independent from another consumer that consumes it in real time. And this replayability of data is another huge benefit built into the Kafka system out of the box. And while JMS brokers have some kind of persistence, again, everyone has different persistence, so you need to check with the vendor. It's not really built for replayability. Yes, it has persistence for high availability. That's critical. And that's what typically JMS people mean. On the other side, you cannot replay data so that one consumer gets it in real time and another one gets it a year later. So that's what you typically work with another cache system adding into the broker or so on. So this is very different apples and oranges you can choose. And so really think about your use case and then choose the right problem. And so that's the last thing here for this long discussion now. That's why I still think also in the future we will see both platforms, right? Because they have very different use cases. Like as Clement mentioned, like if you integrate with legacy systems like mainframes, they have a very good MQ interface, right? So for that, it's a perfect thing to integrate. So most of our customers, they integrate with mainframes via IBM MQ, via the JMS API, and a lot of proprietary protocol things on top. But then they use the Kafka Connect connectors to combine both systems. So these systems are much more complementary than some people think. And it's really better to learn how they use them. I've also seen a customer who tried to re-implement the JMS patterns on Kafka. That will fail. Things like request reply can be done with Kafka, but it works very differently. If you try to do it the same way like JMS, you will fail.
So much good information there. I saw Clement, you were shaking and nodding your head at various points. Would you like to contribute anything more to Kai's comments?
Everything that Kai said is absolutely completely true. Typically, request reply based construct in a GMS based system. Completely, I will even say anti-patterns in a Kafka-based system. So if you want, you believe you will get it right. And believe me, you won't, because you are going to create dynamic topics. It has impact on the broker, or using specific keys, but then you need to have your partition well done and things like that, because of the batching on both consumer and producer too. It can be very, very weird. Like if you have linger time on the producer side, I have seen that a lot. People trying to implement RPC based on Kafka, and I'm always like, no, that's not going to fly. Maybe on your dev machine, yeah, fine, because you have a single broker, single topic, single partitions, everything is fine. That's not your production system. The second thing is the control flow or back pressure. Yeah, right, okay. Kafka consumers are doing a poll things. So they are polling, and a lot of people believe that it's the key to do back pressure because you can decide when to poll. Well, that's not, you need to read the small print of the Kafka documentation, because if you do that and you decide, yeah, I'm polling here and I'm polling in 1 hour or something like that, well, there are some timeout and heartbeat, and actually the poll method of Kafka is probably the most misunderstood method of Kafka, in the sense that it's not only going to poll. It's actually the last part of the poll method. It's when it fetches the records, but it need to locate the coordinator of your consumer group. It need to be sure that everything is there. You have heartbeat and things like that. And if you don't call poll enough or frequently enough, the coordinator, which is one of the broker of your system, will consider you as dead and lead to what all Kafka developers absolutely love, a rebalance protocol, which is also something where we can talk hours about just explaining that protocol. So you need to be very careful that, yes, poll will let you do some back pressure control, but you need to understand a little bit more to implement it right. You need to continue polling, but maybe you don't have the capacity to poll, because if you don't want to poll fast enough, it's because it means that you block somewhere else. So that means you need to pause all your partitions and then resume them. So that's all features Kafka provide. But they are, again, it's very flexible. It's a toolbox where you can do almost plenty of things. But you need to understand, because, well, in my personal life, I have a huge toolbox with every drills and things like that. I have no idea how to use them. So that's Kafka is a little bit the same thing. You have really, really powerful things, powerful tools, but you need to understand. And one of the things Kai says is actually one way to compare against the comparison, as Kai says, it's not really right thing, is that Kafka brokers are relatively dumb in terms of delivery. Be careful, it's still very complicated how it's done, replication and things like that, leaders, rebalance and things. But, well, it doesn't do much. It gets right to segments and to partitions and allows you to read. JMS broker on the other side tends to be I won't say smarter, but have a lot more features like filtering, routing, and things like that. It was made in different time for different purpose. Are these filterings and routings used today? Yes, they're still used, but I would say less than before. We tend to have specific applications that will read and do a specific routing after that, like what Kai's mentioned, Camel, like Camel is doing. So you will do that on the consumer side and not necessarily on the broker side. But you have this possibility. About replayability, I completely agree. JMS has not been designed for replayability at all. It was, I would say, when JMS was designed, it was just not a requirement. We were not doing so much data in motion like we do today. The explosion of the number of data we are collecting every single day, even just right now, has just completely changed. And yes, this data in motion and this replayability are key now in some use cases, while 20 years ago they were not, and that's why it was not necessarily part of the API. As I said, for request reply, don't do that with Kafka. It's not necessarily made that. Don't try to implement replayability with JMS. It has not been really designed for that. And you're going to have lots of headaches trying to make it work. Yeah, sure, I can make it work on my local machine. No problem. That's not a production system.
And the funny thing is really how much in agreement we are, right? I'm not surprised about this. The audience might be, because simply we know that these are very different systems with very different benefits. I have a few comments on also what you said, whereas again, I more or less agree, right? The most interesting thing was the last thing you said, where now we have more data in motion, like you call it, right? And that's also when I talk to customers, and for me it's often hard because I'm in the early stages with our customers, and I need to explain this paradigm shift. So it's very different than the past. So in the past, systems were built like you have a message, you send it somewhere, you store it in a database, and then you have a web service calling it again, right? So this is the old pattern, and this is what JMS was built for, and where it works very well. So again, as Clement says, so don't try to rebuild RPC, real procedure calls with the web service APIs and request reply. With Kafka, that's not how it works. With Kafka, you have the data in motion. It's continuously flowing. That's a new thing for many people, and that's the hard part about it. But for many of the use cases you build today, and it doesn't matter what industry you're in, it's a huge added value if you can act on data in real time. And that's more than just storing it in a database and wait until someone picks it up later. It's about continuously correlating the data. And this is the huge strength of Kafka. And again, here now we're not just talking about the messaging part, because that's still just sending data from A to B, whatever the producer and consumer are. The correlation is the huge, powerful part. And then with Kafka, the huge advantage is that you have an end-to-end platform with a single infrastructure. I've seen customers that try to build similar things with a messaging broker, with an integration framework, like Camel, right? Then also with a correlation layer, a stream processing framework like Flink maybe. And still they needed some other persistence to store the data long-term, for replaying it later, for using it for data science, for using it for compliance, regulatory reporting, and so on. With Kafka, you get the whole stack end-to-end in a single platform. And especially when you're not talking about analytics, but about transactional workloads, the customer will be very happy if it's only one platform and one vendor and one support behind that model. And that's, I think, one of the key differences. But once again, don't try to re-implement your RPC and well-known design patterns with Kafka. It works differently. And this is the paradigm shift, which provides the data in motion concepts, but it's very different. And this is not just true for Kafka, but it's the same like if you use Apache Flink or anything else. It's a very different paradigm about how to use data continuously in real time. You have concepts like sliding windows. Always monitor the sensor data of the last 30 seconds continuously. That's something what's built into Kafka because it's an event streaming platform, but that's not what a message broker does for you. And you need an additional tool for that. And I think that's really the key foundational difference. And then one other thing now, which Clement already mentioned several times, is about the operations complexity. And here also we are in total agreement, right? So Kafka is built as a distributed system. And while you can use it on your development laptop as a single broker and client, and the same is actually true where we see some edge use cases where you deploy a simple broker like in a drone, right, in a hardware. But that's a niche use case. 99% of use cases, Kafka is used as 24/7 highly available system, and therefore it's a distributed system. It has huge advantages for business continuity, guaranteed no data loss and no downtime, even if systems go down. That's also where Kubernetes and so on come into play. But with that, of course, you have complexity of the operations. It's harder to operate than a simple JMS broker. So for that, the key point is, and I think that also where vendors like Red Hat and Confluent agree, because we both have an operator for Kubernetes, right? So that you can take over much of the effort of this complexity that's added to the brokers because Kafka is more complex. Where again, the framework is built by the experts to operate it for you so that you do things like rolling upgrades automatically instead of doing that by yourself. And the last part of on the complexity, and that's also something what people underestimate in this comparison. So if you're in the cloud, you shouldn't care about that at all, because in the cloud, you get serverless offerings which take over this complexity. So at Confluent, we are running thousands of Kafka clusters. We know how to do it well. And we also do it for you completely. So it's a serverless offering. And with that, you don't have to care if it's a distributed system, how you do rolling upgrades, how do you do the rebalancing on the broker side. That's complex things. If you need to do that by yourself, it's hard. We can also support you. But in the cloud, you don't have to worry about that. You have a model with consumption-based pricing and mission-critical SLAs, and you just use it and focus on the business problems. And this is also the reason why now we see this big shift to data streaming much more in the cloud, because here for customers, it's much easier. On premise, they can easily operate the brokers, and Kafka is more complex, even with Kubernetes and operators. In the cloud, you just use it and start small. And when it works, you scale it up in a serverless way. And this is also the difference is why we see this huge adoption of Kafka, especially in the cloud, because it's much easier to adopt, because you don't have to worry about these things that much. And that's, by the way, not just true for the Kafka core messaging part, but for the whole ecosystem. If you need to do data integration with your existing systems, like a message queue, but on the other side, your cloud data warehouse, then you do the integration out of the box with the same system, because Kafka Connect is also fully managed then. And the same for the data correlation with the stream processing part. This is fully managed. You just write your SQL query, deploy it there, and you run it there under the hood serverless. And this is also this kind of difference, I think, where we see it going these days. People want to build business applications and not worry about the infrastructure. This is true in general, not just for Kafka or messaging.
So one of the key differences we are seeing these days in both usage of JMS and Kafka is a representation of the data you are sending or consuming. Kafka on one side is, I don't know if it's recommending, but a lot of people are using a schema-based approach, using Avro, which is the most popular in the Kafka world. Can use protobuf too. JSON schema start to be a little bit more popular than it used to be. You can still use pure unstructured objects, and there is no problem with that. But we start seeing this. I want to have a schema to manage my things, my version, and so on. JMS on the other side, well, because it still is a Java centric, has used Java serialization. So basically, you were writing your Java objects, you were serializing them into byte arrays using the Java serialization framework from Java. So, and on the other side, it was rebuilding the objects. So basically, you have your class, and you can rebuild exactly the same class on the other side. So you don't necessarily have to think too much about the serialization and deserialization. It's less and less true these days, in the sense that, well, Java serialization has not been the most successfully applied things over the years, and it didn't really age well. So we start seeing more mapping to JSON or things like that, but not really schema-based. But basically, you don't need to think about anything. You just, it's going to serialize, send it, you rebuild on the object. While with Confluent and this schema-full approach, you need to think about the schema. So is it a bad thing or a good thing? In general, I would say it's a good thing to think about your schema. It's always a good thing to have to think about how you are going to structure your data and evolve your data. But again, it's for the developer that just want his work done. It can be something, it's an extra thing to think about.
Yeah.
Yes.
I mean, maybe also from my side, first of all, it's important to understand that in Kafka, as I said, the broker is dumb, so you can send anything. It can be any proprietary bytecode or whatever. It's just a byte array on the Kafka broker. That's why it scales so well, by the way, and much better than a JMS broker typically. But typically, it's true. So most of our customers actually use a schema registry. And this also, however, shows the different patterns where people use it, right? So with JMS, you typically send it and someone else consumes it, and that's it, right? In the Kafka world, I would say that 95% of microservice architectures today use Kafka under the hood, not just for the true decoupling and the backpressure handling and so on, but also because with the schema-based approach, you can just send data there, and you can be sure that everybody can consume it. Because reality is, while many customers start with one first pipeline, get data out of your mainframe and put it into a cloud data warehouse, in most cases, more and more different applications and business domains consume the same data. So you have very different people and teams and developers consuming it. And with that, also very different technologies. So the first team might use Java. The second team directly says, no, I just integrated for data warehouse. I just use Kafka Connect. I don't code it all by myself. I just configure it. And the third team is the data science team. They use the Python client and consume the data in batch from the last 30 days to train analytic models. And therefore, Kafka is definitely built so that everybody can use it. including commercial tools and so on. So all commercial tools today, like other middleware, also have Kafka connectors because it's used everywhere. And with this, I think to make this discussion shorter, it's again the same case like we discussed. JMSs send data in and someone else consumes it. With Kafka, it's a much more broad ecosystem and spectrum about how to use it. And I think that's the big difference. And that's true why we see most people are using the schema registry, because then it's a huge benefit, because you have still the guarantees that you cannot send malicious messages, because it's enforced on client and on server side that the schema is used the right way, because otherwise in a microservice architecture, all the different client applications would crash, right? And therefore, this is definitely trade-offs again. But for most Kafka use cases, it's a big pro.
Lots of great points, both sides of the conversation there. A lot of agreement as well. I was expecting a little bit more debate, but actually there was a lot of agreement there on the common topics. But that's a good thing as well. There seems to be some common use cases for both platforms, and a lot of life. I think we both agree it left in JMS. So I think a part of the reason this topic comes up and there's still interest in the topic is they're seeing JMS used in the enterprise, but of course Kafka is the cool new kid on the block, even though it's been around for several years now. But wondering if they should still be using JMS. It's great to hear from two experts that there is some very clear use cases for JMS, and it's got a lot of life left in it yet. I want to thank you both for joining us today for our first Technology Smackdown. It was super interesting, super passionate. You both obviously love this space. It's been a pleasure to have you both on the program.
Thank you.
Hey listeners, thank you for joining us in this round of cocktails. Please like and subscribe to check out other episodes of this podcast series. We're also available on your favorite podcast platforms, or you can simply listen in at torocloud.com, where you'll find full episode transcripts and show notes. On behalf of the team here at Toro Cloud, thank you very much for listening to us today. This has been Kevin Montalvo for Coding Over Cocktails. Cheers!